Hello, everybody, and welcome again to my home. I am Patrick Rowley from the James E. Richmond Science Center, here again to show you more information that you can see with the SOSx, or Science on the Sphere Explorer mobile app that you can get for your phone or tablet. And it's a NOAA app. That's the National Oceanic and Atmospheric Administration. And so we're going to start today with this image here. It's a true color image of Earth. So let me go ahead and make that a bit bigger for you. All right, there we go. All right, so what we're seeing here is an image of Earth that's a little different than what you may have seen if you've been to the Science Center and seen the Science on the Sphere there. I haven't shown this one a whole lot there. So we're looking at the clouds as we would normally see on a lot of the data sets. But what we're seeing here differently is the color. It's more true to what Earth would look like if you were in space and you were looking back at the Earth with your own eyes. So this is based on two of the US NOAA geostationary satellites, or next generation satellites. That's GOES 16, or goes east, and GOES 17, or goes west. All right. So along with a lot of other new capabilities, these are able to generate, we're able to generate images with a near true color. So what we're seeing here, if I pause it right there, we have some daytime imagery. And at that point, we're using the red and blue channels along with kind of a simulated green color to show the land, okay? And so this is able to show it with Earth in a near true color, okay? And so when we're looking at the data set on the Science on the Sphere, back at work, the real-time one that we usually see back at the Science Center, we're looking at just kind of an infrared channel of the clouds on top of a still image of a land-based image, okay, to get that true color look. So here, this is actually the blue that you would be seeing at that time. Now, if we go to a time at night, let night kind of fall here, and pause it, you'll see we have a few different colors in the clouds, right? So we have some kind of bluish color versus the white clouds there. So the blue indicates a low level clouds, and white indicates higher level clouds, which are usually going to be those with a little bit more severe weather in those. And so this is using that infrared data. So we're able to see the clouds at night because you wouldn't be able to see any kind of visible imagery during nighttime because there's no sunlight reflecting off of the clouds, right? And then this is mapped over that Earth at night image that you may have seen before, and we'll be looking at that a little more closely as well. So another thing to notice, if I spin the Earth around here, you'll notice we lose the data. That's because we're only looking at the Western Hemisphere with these two American geostationary satellites. Now the GOES 16 and GOES 17 are able to provide around 4 times the number of wavelength channels as the previous generation of geostationary satellites, or GOES satellites, and also provides us with much more, I guess, faster imagery, right? Every 15 minutes as opposed to 3 hours with the previous generation of satellites. So speaking of all these satellites, let's take a look at the satellites themselves, right? So we're gonna go down here to the space category and go to satellite positions. Okay, now this is something that we can't really do with a real Science on the Sphere. We're able to see these satellites all around the Earth at the right distances, right? On the Science on the Sphere, they're all kind of more in 2D, ironically. So in this place, we're able to see the satellites farther out. So I'm going to turn off all these different layers first. And we're going to start with those geostationary satellites, right? And these are the NOAA geostationary satellites. So if you look way off this way, you'll see some of those GOES 16, for example, and GOES 17 that we just talked about, along with 2 older GOES satellites that are still out there. So we're able to spin the Earth around, and you'll see those kind of move as the Earth spins as well. Now those are your NOAA geostationary satellites. There are plenty of other geostationary satellites out there. And these, for the most part, are pretty close to the equator. You'll see they're all kind of lined up together as I spin the Earth around here. Now, that's our geostationary satellites. We also have what are called polar orbiting satellites from NOAA. And these, as you can see, are much closer to the Earth, around 500 miles, or a little less actually, above Earth's surface, and as they rotate around the polar regions for the most part. And so they collect a narrower band or swath of data as they move around the Earth. And give us really high resolution data to be used for imagery as well as modeling. Now, that's just the NOAA ones. We can also add other weather satellites out there. So if I add all the geostationary and weather satellites there, we can see all of those there together. And then we can add on GPS and space stations, and it's a lot out there, right? So that's how we're able to get a lot of the images we see here. So we don't have a lot of time left in today's little session. So I just want to show you a couple of favorites that are definitely from using satellite data. One is sea ice concentration, right? So here, if we look at just the Arctic, for example, this is looking in the Arctic in September only, from 1987 to 2018. So that's the Arctic sea ice minimum each year, happens in September at the end of the Northern Hemisphere summer. And so as we go forward in time, you'll see that amount basically start to decrease as we go forward in time. So this is at the same time of year every year from 1987 through 2018 to show you the difference there. So he's looked, this is 2018, and we go back, you can see the big difference there between 1987 and 2018. I can zoom it in there a bit and see the difference there. All right. And one more, or actually two more. One that I want to show you is one that might surprise some people, that it's actually from satellite data. This is a popular data set back at the Science Center. So we're going to start with this image of Earth with kind of our land and ocean. But you'll notice as we play the data set, it's actually draining out the ocean water so we can see the bottom or the ocean floor. So let's get to that point there. And this is the bathymetry of the ocean floor, basically. It's the mountains, the valleys, all those landforms on the ocean floor. And what's interesting is you'll see all of this information, all of the entire ocean floor. We have not had sonar ships cover the entire ocean floor. So the way we're able to get this is because of an instrument on satellites called a radar altimeter that's able to actually look at the surface of the ocean and get us a good enough idea of what the ocean floor looks like, all right? When you have the sonar ships, they're able to get a much higher resolution data, but this gives us a good general idea, like the mid-Atlantic ridge there that you see right in the middle of the Atlantic Ocean there. We're able to see that, and that's because of satellites, right? And one more, another favorite we'll finish up with is our nighttime lights. So this actually is from 2012, and it's a composite image, or a mosaic rather, because it takes a while, right, to get all of the Earth at nighttime and with no clouds, right? And this is from one of our newer polar orbiting satellites, the SUMI NPP satellite. And we're able to then see the Earth at night. And these are all filtered out to only show human-made lights, so lights from electricity, right? So we can see where some of the big population centers are, or at least population centers are that have a lot of lights on, right? So we can look over here and see, for example, some parts of the world that have a lot of lights on. Japan, China, South Korea there. Compared to Africa, it doesn't have as many lights, except for right here along the Nile River. If we zoom in on that, you see the Nile River area there, the cities along that. And then if we come around back to the US, you can see the eastern half of the country, especially the east coast of the US, has a lot of lights there, right? All right, well, that's it for me today. You have a good weekend coming up. And stay safe, wear a mask, stay inside as much as you can. And we'll see you next week.